Signs of existence of proton in an atom were observed way before the discovery of electrons. In the year 1886, a Geisenheim physicist, Eugen Goldstein, performed an experiment similar to cathode ray tube experiment. Let's learn about this experiment of Goldstein. Goldstein's setup was inspired from Crookes's setup. It had a discharge tube with 2 electrodes, but instead of tube being almost empty, Goldstein filled it with hydrogen gas. He also switched the position of cathode and anode electrodes. Instead of normal cathode plate, Goldstein used cathode plate containing hole and placed a fluorescent screen behind it. At that time, it was already known that hydrogen was smallest element. When Goldstein applied high voltage, he observed the bright red light behind perforated cathode. Since these rays were traveling from anode to cathode, they were called anode rays. Goldstein performed following extra experiments to confirm different properties of anode rays. He placed an object between cathode and screen and observed the shadow of it on the screen. This proved that anode rays travel in straight line. If a paddled wheel was kept in the path of rays, it started moving. This suggested that these rays have mass. Goldstein applied electric field from sides of the tube and observed that rays have bent towards negative terminal. By this, he concluded that anode rays or protons are positively charged. Unlike cathode rays, anode rays were dependent on type of gas filled in the discharge tube. Not until Rutherford performed his famous gold foil experiment in 1911, that protons were really confirmed. As a result of his experiment, Rutherford was able to confirm that atom's nucleus is positively charged. Between year 1911 to 1920, using observation of Goldstein and gold foil experiment, Rutherford came to conclusion that positive charge of nucleus is because of positively charged protons. In an atom, numbers of protons are equal to number of electrons, and thus an atom is naturally neutral.